To determine the appropriate cable size for a 12 volts 750 amps application with a short run of approximately 4 feet, several factors must be considered. These factors include the ampacity of the cable, the allowable voltage drop, and any applicable safety standards. For a 750 amps load at 12 volts, you'll need to select a cable that can safely handle this high current without overheating or causing excessive voltage drop. Firstly, ampacity refers to the maximum amount of electrical current a conductor can carry before sustaining critical damage. The National Electrical Code, or NEC, provides ampacity tables for various conductor types and insulation ratings. These tables, such as those found in NEC Table 310.15, take into account factors like the conductor material, insulation type, ambient temperature, and the number of conductors bundled together. When selecting a cable, it is crucial to ensure that its ampacity rating meets or exceeds the load current of 750 amps. Secondly, voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can lead to reduced performance of connected equipment, overheating, and even equipment failure. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use Ohm's law, which states that voltage equals current times resistance. The formula for voltage drop is voltage drop equals current multiplied by the length of the conductor multiplied by the resistance per unit length. The resistance per unit length depends on the conductor material and size. For copper conductors, the resistance per 1000 feet can be found in NEC Chapter 9, Table 8. Aluminum conductors have a higher resistance than copper, so the voltage drop will be greater for the same conductor size. Thirdly, the American wire gauge, or AUG, system is a standardized wire gauge system used predominantly in North America for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the wire diameter and the higher its resistance. Conversely, the smaller the AWG number, the larger the wire diameter and the lower its resistance. For high current applications like 750 amps, a large gauge wire is required to minimize voltage drop and ensure safe operation. Now, let's consider the specific scenario of a 12 volts 750 amps load with a 4-foot run. Because of the high current and short distance, voltage drop is less of a concern than ampacity. The primary focus should be on selecting a cable size that can safely handle 750 amps. Based on NEC tables, a 4/0 AWG cable is a suitable choice for carrying 750 amps in many common installation scenarios. However, it is important to verify this against the specific conditions of the installation. Factors such as the insulation type, ambient temperature, and whether the cable is installed in a conduit or free air can affect its ampacity. For example, if the cable is installed in a hot environment or bundled with other conductors, its ampacity may need to be derated. Derating involves reducing the allowable current carrying capacity of the cable to prevent overheating. NEC Table 310.15 provides derating factors for various conditions. To ensure compliance with safety standards and prevent electrical hazards, it is always recommended to consult with a qualified electrician or electrical engineer when selecting cable sizes for high current applications. They can assess the specific conditions of the installation and recommend the appropriate cable size and type. In addition to considering ampacity and voltage drop, other factors may also influence cable selection, such as the type of insulation, the flexibility of the cable, and its resistance to environmental factors. For example, if the cable will be exposed to moisture or chemicals, a cable with a suitable insulation rating should be selected. If the cable needs to be bent or routed around obstacles, a flexible cable may be preferred. Ultimately, the goal is to select a cable that can safely and reliably carry the required current while meeting all applicable safety standards and installation requirements. Always double-check the NEC tables and consult with a qualified professional to ensure that the chosen cable size is appropriate for the specific application. In summary, for a 12 volts 750 amps application with a short run of approximately 4 feet, a 4/0 AWG cable is generally recommended. However, it is crucial to verify this against the specific installation conditions and consult with a qualified electrician or electrical engineer to ensure compliance with safety standards and prevent electrical hazards. Remember to always prioritize safety when working with electrical systems and to follow all applicable codes and regulations. Also consider the termination of the cable. A 4/0 AWG cable requires appropriately sized lugs and connectors to ensure a secure and reliable connection. These lugs should be crimped or otherwise attached to the cable using tools and methods recommended by the manufacturer. Proper termination is essential for preventing overheating and ensuring the long-term performance of the electrical system. If the cable will be subject to vibration or movement, consider using flexible cable or strain relief devices to prevent damage to the conductors or terminations. Vibration can cause connections to loosen over time, leading to increased resistance and potential overheating. Strain relief devices can help to absorb these vibrations and prevent them from being transmitted to the cable terminations. Finally, document your cable selection and installation. Keep records of the cable size, type, and ampacity rating, as well as any dirting factors that were applied. This documentation can be helpful for future maintenance and troubleshooting. By carefully considering all of these factors, you can select the appropriate cable size for your 12 volts 750 amps application and ensure a safe and reliable electrical system. And always remember to disconnect power and follow safe electrical practices when working with electrical circuits. If you are unsure about any aspect of the installation, consult with a qualified electrician. To further elaborate on the considerations for cable selection, let's delve into some additional details about ampacity, voltage drop, and other relevant factors. When determining the ampacity of a cable, it's essential to understand the different insulation types and their temperature ratings. Insulation materials are rated for their maximum operating temperature, such as 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The ampacity of a cable depends on its insulation temperature rating, with higher temperature ratings allowing for higher ampacities. NEC Table 310.15 provides ampacity values for different insulation types at various ambient temperatures. The ambient temperature is the temperature of the surrounding environment where the cable is installed. If the ambient temperature is higher than the temperature listed in the NEC table, the ampacity of the cable must be derated accordingly. Derating involves multiplying the ampacity value by a derating factor to account for the higher ambient temperature. For example, if a cable with a 75 degrees Celsius insulation rating has an ampacity of 230 amps at an ambient temperature of 30 degrees Celsius, its ampacity must be derated if the ambient temperature is higher than 30 degrees Celsius. The NEC provides derating factors for various ambient temperatures in Table 310.15. In addition to ambient temperature, the number of conductors bundled together in a conduit or cable tray can also affect the ampacity of a cable. When multiple conductors are bundled together, they generate heat, which can raise the temperature of the conductors and reduce their ampacity. NEC Table 310.15 provides adjustment factors for the number of conductors in a raceway or cable. These adjustment factors are used to reduce the ampacity of the cables to account for the increased heat generated by the bundled conductors. For example, if 3 current-carrying conductors are bundled together in a conduit, the ampacity of each conductor must be reduced by 80%. If more than 3 conductors are bundled together, the ampacity must be reduced further. The NEC provides specific adjustment factors for various numbers of conductors. Voltage drop is another critical factor to consider when selecting cable sizes, especially for long runs. Excessive voltage drop can lead to reduced performance of connected equipment, such as motors, lights, and electronic devices. The voltage drop in a circuit depends on the current, the length of the conductor, and the resistance of the conductor. The formula for voltage drop is voltage drop equals current multiplied by the length of the conductor multiplied by the resistance per unit length. The resistance per unit length depends on the conductor material and size. Copper conductors have a lower resistance than aluminum conductors, so the voltage drop will be lower for the same conductor size. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use online voltage drop calculators or consult with a qualified electrician. These tools can help you determine the appropriate cable size to minimize voltage drop and ensure proper equipment performance. Furthermore, consider the type of load being served. Inductive loads, such as motors and transformers, can draw high inrush currents when they are first energized. These inrush currents can cause voltage dips and stress the electrical system. To mitigate these effects, it may be necessary to oversize the cable or use a soft start device to limit the inrush current. Also, consider the environment in which the cable will be installed. Cables that are exposed to moisture, chemicals, or extreme temperatures may require special insulation or protection. For example, cables that are installed underground may need to be direct burial rated and protected from physical damage. Cables that are installed in corrosive environments may need to be made of corrosion-resistant materials. Finally, consult with the local electrical codes and regulations to ensure compliance with all applicable requirements. Electrical codes vary from jurisdiction to jurisdiction, so it's important to be aware of the specific requirements in your area. A qualified electrician can help you navigate the electrical codes and ensure that your installation is safe and compliant. Let's delve deeper into the selection process for the 4/0 AWG cable, considering various scenarios and potential adjustments. Firstly, the 4/0 AWG cable is a common choice for high current applications due to its ability to handle significant amperage while maintaining a reasonable voltage drop over short distances. However, it's not a one-size-fits-all solution, and a thorough assessment of the specific conditions is necessary. Secondly, consider the specific insulation type of the 4/0 AWG cable. Common insulation types include THHN, THWN, and XHHW. Each insulation type has different temperature ratings and resistance to moisture and chemicals. THHN insulation is commonly used for dry locations, while THWN insulation is suitable for wet locations. XHHW insulation offers both high temperature and moisture resistance. Choose the insulation type that is appropriate for the environment in which the cable will be installed. Thirdly, examine the ampacity of the 4/0 AWG cable based on its insulation type and installation method. NEC Table 310.15 provides ampacity values for various insulation types and installation methods. For example, a 4/0 AWG copper cable with THHN insulation installed in a conduit may have an ampacity of 230 amps at 75 degrees Celsius. However, if the cable is installed in free air, its ampacity may be higher. Ensure that the ampacity of the chosen cable is sufficient to handle the 750 amps load. Fourthly, assess the ambient temperature of the installation environment. If the ambient temperature is higher than the temperature listed in the NEC table, the ampacity of the cable must be derated accordingly. Use the derating factors provided in NEC table 310.15 to adjust the ampacity of the cable for the higher ambient temperature. Fifthly, consider the number of current carrying conductors in the racewire cable. If multiple conductors are bundled together, the ampacity of each conductor must be reduced using the adjustment factors provided in NEC table 310.15. This adjustment accounts for the increased heat generated by the bundled conductors. Sixthly, evaluate the voltage drop in the circuit. Although the run is short at 4 feet, it's still important to calculate the voltage drop to ensure that it is within acceptable limits. Use the voltage drop formula and the resistance per unit length of the cable to calculate the voltage drop. If the voltage drop is excessive, consider using a larger cable size or reducing the load current. Seventhly, examine the termination methods for the 4/0 AWG cable. Proper termination is essential for ensuring a secure and reliable connection. Use appropriately sized lugs and connectors that are compatible with the cable and the equipment being connected. Crimp the lugs and connectors using the tools and methods recommended by the manufacturer. Eighthly, consider the physical protection of the cable. If the cable is exposed to physical damage, such as abrasion or impact, it may need to be protected by a conduit or other protective covering. Choose a conduit material that is appropriate for the environment in which the cable will be installed. Ninthly, consider any applicable local electrical codes and regulations. Local codes may have specific requirements for cable sizing and installation. Consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes. Tenthly, document the cable selection and installation. Keep records of the cable size, type, ampacity, rating factors, voltage drop calculations, and termination methods. This documentation can be helpful for future maintenance and troubleshooting. By carefully considering all of these factors, you can select the appropriate 4/0 AWG cable for your 12 volts 750 amps application and ensure a safe and reliable electrical system. Always prioritize safety and consult with a qualified professional if you have any doubts or concerns.